Here I'm going to show an example of using the Filibuster test plugin for IntelliJ. So for this, I have a sample microservice application where I have a client that will issue a call to a hello service, which communicates with a world service. It issues a couple RPCs and then returns a response back to the end user. And so I've already instrumented the code by adding the Filibuster interceptor to the hello service. And I wrote a functional test that uses this Filibuster test annotation. And what it's going to say is just for every gRPC call that we see, we just want to induce a single fault. And we want to see if it causes any of our assertions in the test to fail when we do the fault injection. So I can simply run this test normally. And the way we usually develop these tests is we develop these tests using the test annotation. And then once the test is working, we switch it to the Filibuster test annotation, which automatically starts injecting faults for any of the services that have been instrumented. Now, once we start running this test, we'll see that Filibuster is generating a number of, it's synthesizing alternative tests where faults are injected. And if we use the Filibuster tab here, we can see that it's currently executing tests. And normally the output that you'd have to examine with Filibuster is just entries in the log. And entries in the log can make it difficult to debug what's going on. And so what the Filibuster plugin will do will allow you to see all of the tests that were synthesized. So we synthesized a few different variants. The first variant is always going to be the golden path execution where no faults were injected. And we could see here that we issued two RPCs from our hello service to the world service. These were the methods that were called, so it happened to call the same RPC twice. It used this request object. Here's the payload. Here's the reply. Here's the response payload. And then Filibuster actually has a linter built into it, which is kind of a dynamic analysis version of error-prone for RPCs. And this kind of just gives us a warning here, because in this example application, we call the same service twice, and we actually use the arguments. We use the response from the first RPC, our Marion world, as part of the arguments to the second. And so Filibuster is just recommending that the application may be more robust if we issue fewer RPCs and try to provide a single RPC that gives us everything that we need. Now, in the alternative test executions, we'll see that there was one execution where we failed the second RPC. Here, we injected a status runtime exception with code unavailable to simulate the remote service being down. And then in the third execution, we failed the first RPC, which prevented us from executing the second RPC. And we see that it was the same fault that was injected here. And so if you were injecting many different faults, like unavailable, timeouts, or whatever, you would see many, many more test executions, and it would search the space exhaustively. So we'll try all permutations of all possible errors. Now, in this case, we don't have any failing tests, but if you did have a failing test, we would indicate that the test failed here, and we would see that test in red over here. So this gives you a good overview of what's happening. So this is a nicer way to visualize the results of using Filibuster on your applications without having to scroll through logs and try to figure out where the faults were injected, which can be difficult when you're working on microservices that issue 10, 20 RPCs as part of a single functional test.